Thank you. It's great to be here. I'm going to start out by making you depressed, and then we're going to switch to optimism. What I want to talk to you about is first the trends in energy and climate change, especially in climate change, that should have you very nervous. They're much worse than most people realize. Then there are these fantastic opportunities, new technologies that are actually growing at unbelievable speeds. And then finally, to talk about the difference between business as usual trends, which are terrible, and the possibilities, which are quite bright, and what we need to do to capture the difference. I'm an engineer, so I start with a graph. And this is a graph of temperatures in America. And like any normal distribution graph, you have a third of your years are cooler than normal, a third are normal, and a third are warmer than normal. Now, climate scientists talk about average shifts in temperature because that's an easy way to measure things. But it turns out that's not what matters. What matters is extremes. So watch what happens in the real world. This is all using NASA data. And as you can see, the entire band of temperatures has moved to the warmer side. The consequence of that is while we used to have 1/3 cooler, 1/3 normal, and 1/3 warmer than normal temperatures, we now have 1 out of 12 years is cooler than normal. 1 out of 6 is normal. 4/6 are warmer than normal, and 1/12 are extreme. And it turns out that it's those extreme temperatures that drive the experiences and indeed our ability to sustain the planet. Let me show you what extreme temperatures look like. Last year, 2/3 of America suffered a drought, and in some states like Texas, it was the worst drought since the Dust Bowl. Corn production was down by almost 30%. This is a farmer in Illinois who's not having a good year. Many of you remember 2 months ago in Colorado, they got an entire year's worth of rain in 2 days. That's extreme. That's what weather extremes are, and we are not equipped to handle those kinds of extremes. It's not just us. More than half of Bangladesh, a country of 150 million people, has been underwater. A year ago, 2/3 of Thailand's counties were underwater. That's extreme weather. It's been apocalyptic in Australia early this year. The average temperature on the entire continent was 106 degrees. And in some places, it was over 120 degrees. 2/3 of 1 million acres burned in Australia. This is what an extreme temperature looks like. Hurricane Sandy was just over a year ago. We're thinking about the anniversary. 72,000 homes and businesses in New Jersey were destroyed. It was a 1,000-kilometer wide storm. You think we're equipped to deal with things. We are not equipped to deal with extreme weather. And it's physically impossible to deal with extreme weather in some circumstances. We're looking at about a meter sea level rise this year. Within 200 years, 150 years probably, Miami's uninhabitable. You can't put a seawall around Miami because it's permeable limestone. So we're changing things pretty dramatically. Now, we're not done depressing you. This is the other side of extremes. We've lost the cold. And extreme cold kills these little teeny pine beetles. And if they thrive, pine trees die. So now we have 10 million acres of dead pine trees in America. So if you want to see what extreme weather looks like, get in an airplane. Go visit the Rockies, now on the East Coast. Human beings are affecting the climate. We're doing this. But if we go too far, nature takes over. There's this thing called, scientists call it positive feedback, but most people think that's a nice thing. So I call it a vicious cycle, or runaway feedback loop. And here's a couple of them I'm going to show you. This is ice in the Arctic. 1980. It's white. The sunshine comes down, it hits the white, it bounces off. This is what it looks like today. It's half gone. The North Pole has been water at times now. But the thing about this is it's now dark. And so the sun comes down, and the dark water absorbs the heat. So you change a mirror into an absorber. So nature takes over and accelerates what we human beings have done. Here's one that's worse. The entire North, millions and millions of acres in Siberia, in Canada, and Alaska is this tundra. This is essentially frozen peat bogs, and they're packed with methane. Methane is the main component of natural gas. It's a very potent greenhouse gas, 30 times as potent as CO2. If you defrost the tundra, the methane comes out, and it accelerates. It becomes a runaway. So it turns out The mathematics of climate change are such that if we do not reverse trends quickly, and by quickly I mean in our lives, in the next 20 to 40 years, this thing will run away. By the way, we've already reached a point of higher CO2 concentrations than have existed on the planet for more than human existence, for more than 3 million years. So we're experimenting with some big stuff here. Okay. Ready to come back? There's some other runaway trends that are happening that take us from fear to hope. And here's one that I like, another graph. Solar panels. You see them all over San Diego. In fact, University of San Diego is going to have 100% of its buildings that are feasible covered with solar panels on top. But what's happened is the price of these things has gone down 80% in the last 5 years. And when you do that to the price, this is what happens to the use. People are installing these things like crazy, and it's happening with wind. And there are opportunities with other renewable energy resources as well. So what does this mean? Can we scale, can these dramatic technology differences scale and give us what we need to get out of this problem? It's happening. Texas has more wind power than any other state in the country. 12.2 billion watts of installed wind. It began when George W. Bush was governor. He signed the paper that caused the policy to have this done. And it's been an explosive and fascinating experience. This is enough wind to power almost 4 million homes. California, our fair state, has already signed contracts to get 1/3 of its electricity from renewable sources. That's a big deal. In fact, there are now 29 states that have put policies in place to replace our carbon-based fossil fuel system with renewable energy system, step by step. But when the prices drop that fast, each step is cheaper, easier than the one that came before. Other countries are ahead of us. Denmark gets 40% of its electricity from renewable sources. That's pretty cool. If you're 40%, you can see your way to 100%. And in fact, there are days in Denmark where they get more than 100% of their electricity from renewable energy. They export zero-carbon electrons. Germany, a much bigger country than Denmark, started with very little renewable energy 10 years ago. And today, they get 1/4 of their electricity from renewable sources, and they have specific, detailed plans to get that up to 80% by 2050. Now, Germany's a big country. It's an industrial country. It's not very sunny in Germany much of the year. It's frighteningly cold sometimes, and they're doing it. So what about our country? How far can we go? A group of scientists at the National Renewable Energy Lab produced the most detailed model of the U.S. electricity system ever done. They start with today, which is mostly nuclear, coal, and natural gas. They do an hour-by-hour assessment of the entire grid from now to 2050, and they add clean energy bit by bit to this and see how far they can go. And this is what they came up with. That's the future that we can do with technologies that exist or are near term. Now, the more technology that's invented on this front, the better, to be sure. But this is a pretty amazing transformation within 50 years. It's feasible, it's increasingly cost-effective, and it's happening already in more than half the states. It's a matter of choice. That's the deal. These god-awful trends or a reasonable future is a matter of choice. And that takes me, finally, to what we need to do as a country and what you each need to think about doing. So there are 3 things we have to do. The first is we have to manage fossil fuels. That picture of coal is black because it's carbon. And all the carbon in the earth in the form of coal and oil and natural gas, most of it needs to stay in the earth. Our atmosphere simply cannot handle it. So if we don't manage fossil fuels well, we lose. Natural gas, by the way, is people talk about it as a clean fuel. It's better than coal, and it could be a useful transition fuel, but we shouldn't get re-addicted to it because it is a fossil fuel, and it doesn't buy us all that much time. So we have to manage fossil fuels. Let me mention one other thing about this. There's some interesting ideas to burn coal, capture the carbon dioxide that comes out of the atmosphere, out of the smokestack, compress it, and re-inject it deep underground and hope it stays there for a few thousand years. And I would say, guys, wait a minute. It's already in the ground. Let's just leave some of it there. Okay, we need to manage fossil fuels. Second, we need to stop wasting energy. This is a Nest thermostat. You've probably seen these. They know whether you're in the house or not. They know how cold it is outside. They know the patterns, the energy patterns of your house. And simply by putting in that little thermostat, you save about 20% of your energy. That's a pretty good deal. California houses now use 80% less energy in a new house than they did before we established the best building code in the world. If we stop waste, we can reduce waste by 50 to 80% in almost every sector. In fact, California's official policy is to have all new residences built in this state by 2020 to be zero net energy buildings. That's a pretty great deal. So we stop energy waste is the next thing. The third thing is we need to accelerate renewables, and I've already discussed this. The people who decide how much renewable energy you get are the public utilities commissions in each of the 50 states. It's not primarily the US Congress. These are state government bodies. They're not ineffectual. They're smart. They deal with evidence, but they need to hear from you that this is a future you prefer. So let me take you to the last slide here. What is your role? So I've said the difference between these fearsome trends and a really bright future is a matter of social choice. It's a matter of policy. It's a matter of how we decide to invest our existing cash flow in energy. People come to TED conferences because they want to learn and because they want to give. And everybody here has an amazing network of relationships, of people. Everyone here is an influence maker. So I'm saying to you, use your influence. And the way you do that, inform yourself and be optimistic. Nobody likes to hear from somebody who doesn't know their business or from somebody who's perennially depressed, right? And then choose a decision maker, one decision maker, and get into that person's life. It might be your landlord. It might be your chancellor. It might be the interim mayor. It might be your congressman. It might be your public utilities commissioner. But sit down with them and let them know, as you understand yourself, that this is a social choice we have to make correctly. And I promise you one thing, if you study this subject, you'll realize, well, we have options today, and we can land on a reasonable future. If we lose a decade, we foreclose an increasing number of reasonable options. If we lose a couple decades, we will trigger those vicious feedbacks. So it's time for each of us to do our part to make sure we win this game. Thank you.